Okay, so without wasting any further time, I think this is a topic I really love to talk about because this is something that uh, did not come with my education, but it actually turned out to be something that was a requirement when I joined the corporations because data is something that is the backbone of any industry. Now, what do we do with the data really helps the organizations to maneuver where they want to go. So what I'm going to talk about today is one of the methods of doing some data analytics. Now, this is not the only way. I will be very, very candid. This is not the only way, but this is something that I have learned or gained over a period of time working with different corporates, collecting data, analyzing, making sense of it, and more to do with because one of my certifications and one of my key roles is a change agent. Now, what a change agent is, and change agent is somebody who looks at the status quo and challenge it and try to look for different things, that how can things be very different in a positive way. How can I reduce lot of um, cost factors? How can we make better business decisions? How can we utilize the resources that we have at hand and make the optimal use of it? I'm going to share my screen. I've put together a presentation, and after tomorrow's day, I will also be sharing this presentation with the EduBridge team, and they can pass it on to all the participants who will join today and tomorrow's session as a takeaway. Now, I am going to divide this into two parts. One is core data analytics, and then the Excel part is separate because Excel is something that we're going to utilize for data analytics. Now, we don't only have Excel for data analysis and data analytics, but there are a lot many more data analytics softwares that are now in the market to do a lot of analysis, lot of learning on those data sets. I will talk about those technologies as well, but our focus today is only going to be how do we do it with Excel. Now, to begin, this is what we're going to talk about in the 2 days that we have. Time is very limited. The topics are so vast that it takes a lifetime of a person to really get into the depth of data analytics. And I'm also in a path of turning into a data scientist myself. So learning never stops. I'm going to share a lot of practical experience examples that how I have used these tools to get some insights, to make changes, and to get better decisions from the top leadership. So these are some topics that we're going to cover. These are just bullet points, but there is a lot more inside each of these bullet points we are going to learn today and tomorrow. All right. So to begin with, to set the stage, let's talk about what analytics is all about. Okay, and I'm going to talk from a very dictionary kind of an outcome or on the definitions of these terms that we're going to use. Because learning these terms is very important because a lot of people I've seen use a lot of terms interchangeably. And that's not the correct way of approaching to these terms. Because when you are in a discussion with somebody, the terms that you basically are going to use really helps the other person understand how much do you know about this subject. Okay. Now, as we go with the definition of analytics, it is very simple. It says analytics is defined as a scientific process. Okay. So just underline the keywords. It's a scientific process of transforming a data into insight for making better decisions. Okay, and that is what analytics really helps us to do. It helps us to get insights from the data that we have so that better decisions can be taken. Now, there is another term that we widely use, and that is called analysis, right? And you may have also come across this term, analysis, analytics. Now, is it same? Is it different? What are these terms all about? So I've put together, certain definitions on both these terms, and then we'll talk about how these two support each other, or are they really different? So analysis, as per the dictionary definition, it says it's a process of breaking a complex substance into smaller parts to gain better understanding of it. It is a technique that has been applied in the study of mathematics and logic since before Aristotle. So even before 384, 322 BC, these things have been in practice and in use. As a formal concept, and is relatively with a very recent development in analysis. And analytics, we already looked at what the definition is, but analytics is more of a multidimensional discipline. There is an extensive use of maths and statistics, and the use of descriptive techniques and predictive models to gain valuable knowledge from the data. Now, are these two terms different? Yes, they are, but they support each other. When you talk about analytics, you cannot isolate analysis from it, because analysis becomes part of your analytics, whatever you want to achieve, what you want to drive. Now, there are various analytics models and techniques that are talk of the town. And as we speak, a lot of other scientists are defining new terms, new terminologies, new technologies giving it to us. What I've learned and what I want to share with all of you, that there are 4 different types of analytics that are mostly out in the market, and most of us talk about them. To start with, we have the descriptive analytics. Now, descriptive analytics is about collecting some historical facts data and analyzing those data to see what happened. Okay, so basically, if I've done something, I'm going to collect some data to see what that data reveals as what did I do in my process, or if anything that I've done. Then another field is called diagnostic analysis, where if there is something that needs to be changed, or if there is something that has not worked the way we wanted it to work, then we need to ascertain the reasons from that historical data that we've collected. So basically, it is going to help us get an answer to why did it happen. So the why part of it. So what happened and why did it happen? Then another field is called predictive analysis. What is going to happen in future? So by collecting historical data, we're going to put those data sets into certain models, certain statistical models, certain machine learning techniques to predict the future. That if something happened in future, can I learn from it and predict what can happen in the past and what can happen in the future? And then the most complicated part of analytics, which is still a talk of the town, and people are still trying to make head and tail of it and trying to ascertain how to better use this part of analytics, which is called prescriptive analysis. That says that how can we make it happen? So I need to do certain things. I need to do certain things differently. By learning from what has happened in the past, how can I use that to say that how will I do my business tomorrow, or how will I do certain things that I've done in the past in a different way tomorrow? So basically, prescriptive analysis talks about recommendations, decisions, using some optimizations and simulations. I'll just take a few seconds pause to see if anybody has any questions till what we have covered so far. Learners, please stop scribbling on the screen. Silence. Okay. Okay, now let's get more deep into what data analytics is all about. So what is data analytics? Data analytics is nothing but it is a science that helps you extract certain patterns or certain relevant information from what we call quote unquote raw data, and we will draw certain conclusions from that raw data. That is what data analytics is all about. It has got multiple approaches, it has got multiple dimensions, and it has got diverse techniques, and those techniques are evolving over a period of time. Ever since I've started learning, looking at data, making sense of data, the things have changed inside out from what I started and what it is now. Even the technology has changed so much that it is difficult for each one of us to keep pace with that ever changing technology. The moment you start learning certain things and you have learned something, the things have already moved ahead, the things have already changed, so there is something new that needs to be learned. But that's exactly what I teach everybody, and I want each one of you to focus on the very basic things of data analytics and then build on top of it. And that is what exactly I also do. So I keep the basics and then I build on those basics as the new methods, methodologies, they come in. So at some point in time, I'll also talk about, what are these new techniques, new terminologies, new technologies that are helping in data analytics, and specifically in all those 4 different types of method techniques, which is descriptive, prescriptive, and all those 4 sections that we looked at on the previous screens. Now, what data analytics helps in? It helps in a lot of industries, and it allows the organizations to make better business decisions. Now, business decisions are very, very important. Any wrong decision can cause a harm to the success and growth of an organization. And taking better data decisions has now become a normal with all the organizations. Now, when data was not there, previously when we did not have too many techniques, then a lot of those decisions by the senior leadership was taken with their own experiences that they had in the past, or with certain insights or observations that they could get from the market. But now when we have a lot of data, we have a lot of techniques to extract relevant information, to extract insights from this data, then today the most of the senior leaderships will not take a decision based on their experience, but they would want the data to help them take better decisions to move forward in the organization. It also helps in gaining profits, making better use of resources. It also helps in improving any managerial operations. Data analytics also focuses on inferences, like what my data tells me. So I infer that thing out, and basis those inferences, I will drive some conclusions to move forward. And most of the researchers also use some historical data to take certain data-based decisions. And not to go very far, the pandemic that hit us in 2020 was something that nobody in the world had seen. And every science community was of concern as to how this virus is going to behave, how this virus is going to affect us and the globe. But now when we have 2 years of data that we have gathered from this pandemic, today the scientific community is able to predict with more accuracy in terms of what is going to happen tomorrow. And they help us, the larger community, to take those precautionary steps and precautionary measures to save ourselves from what is coming. And you would have also heard that now wave 4 is round the corner. Now, how did the scientists know about this wave 4? Is by that data collection and making head and tail from the data and modeling it and predicting. So it is more of a predictive analytics that has gone into the historical data to predict what the future is going to look like. And that's a very, very good example which each one of us can relate to, that how the analytics is really helping us to take better decisions. Now, before we actually get into any analytics or analysis, we need to do certain pre-steps. And this is one of the process flows that a lot of people follow when they actually do some analysis or apply certain analytical tools to gain insights from the data. Very, very important. Step number 1 is you define a goal. It's very, very, very important. You should be able to define a goal, that why are we doing this analytics or analysis? Because if this goal is clear, which means you know what is the outcome that you require, then it will help you design a better method or methodology for you to do this analysis. So if you know the outcome, and that is the starting point of any analysis I have learned in my lifetime. You should be able to define a goal. Then once the goal has been defined, then I should be able to identify some measurable matrices. Now, what is a metric? Metric is something that helps you understand if you are moving in a right direction. I'll take an example. Let's say I walk from my home to my school or my college or my office, as the case may be. And I take 20 minutes to cover the distance from my home to whatever place, school, college, or anything. Okay. Now, what is the metric here? The metric is, the two metrics here. One is that I can measure and track is distance. And the other is the time. Okay. Now, if my goal is to make a change in the distance that I cover, maybe I want a shorter distance from my home to my office or my school or my college, or if my goal is to reduce the time that I'm taking in traveling from my home to my office, then I'm going to identify those measurable matrices. Now, why measurable? Because anything that cannot be measured cannot be improved or cannot be acted on. So we need to find out all those matrices that can be measured so that I know what it is today. Let's say if I take 20 minutes, okay, and I collect this data. So my goal is to reduce the time that I'm taking. So I'm going to identify this time as a matrix, time to travel, more specific. And then I'm going to collect some historical data. Maybe, I'll collect maybe 3 months, 4 months, 5 months, or 6 months of data that I actually took from my home to the other destination. And then I'm going to analyze it. And then I'm going to think whether it can be reduced. If yes, then how can it be reduced? And I can use this to predict that if I reduce this time, okay, then how much time can I save in next 1 year, 2 years, or 3 years? So those are the business decisions, because anything that you save is a saving in hard cash. Okay, so let's say if you take a bike and you travel 15 kilometers every day from A point to the B point, and you take certain time. Now there is a cost involved in traveling the distance. Now, if I am able to save the distance, let's say if I find a better way or a route that saves me 2 kilometers every day, which means instead of 15 kilometers, now I have to travel only 13 kilometers, then I will also save the cost of the fuel that I'm using. Okay, so all that is very, very important. So you define a goal and then you identify a measurable metric that is going to help you focus on what you need to collect. Then once that is achieved, then we will list down all that we need to collect and extract data from different sources. Then only we will know what data, how much data from which source I will be collecting. Once this collection is done, okay, then we are going to explore and analyze the data. Now, this is also a step which is not very straightforward. The analysis, the analytics will always depend on, again, what is the goal and what is the type of data that I have collected. So we'll also look at data types and all of it, because those are very, very important things to know beforehand you jump into any analysis or any analytics. Now, once we are moving with the analysis part of it, we're going to interpret and we're going to visualize the data. Now, data visualization is also an important step in analysis, because visualization means putting data in pictures. Okay, putting data into pictures, which means more of graphical outputs in terms of dashboards rather than only data outputs. So we'll also learn different visualization techniques, methods, how do we make data, convert that data into picture format. So a lot of people can understand. And then finally, we infer from that data for making better decision making. A few seconds pause to see if things are okay. They're bouncers. You're not able to understand anything. Or any questions?
Yes, sir.
No questions?
No questions. Understand, sir.
Fantastic.
Hello.
Right.
Hello.
Yes.
Hi, sir. Can you hear me?
Yes, absolutely, I can.
Okay, sir. So my name is Jyoti. I have a doubt. So how the data analyst process is different from this data analytics? So can you make a little bit difference between these two terms, like data analyst and data analytics?
Data analysis and data analytics. Okay, fantastic. That's a very good question. Coming a little late, but then still welcome. Now let's say I'll take an example. Okay, I run an organization, and my organization has got 100 employees, okay, who sit and answer calls. So in a term, you can say I run a call center, okay, where I only get inbound calls. I receive calls. I've got 100 people who are taking calls. Now I want to do as the owner of this organization, I'm trying to project my next year. Okay, let's say I'm sitting in 2022, and I want some projections for 2023, that how will my organization grow and how much growth I can have. Okay, question is clear?
Yes.
Okay,
Yes.
fantastic. Now, how do I do this? What do you think? What should I do so that I am able to project how will I do in 2023? What do you think?
By using historical data.
By using historical data, absolutely. But then, there's something on your screen already. These are the steps. These steps will not change with any analytics or any analysis. Okay. So number one, I need to define my goals. What is it that I want to achieve? Now, when I say growth, I should be very, very clear or very, very particular in terms of what do I mean by growth. Am I growing my organization in terms of the revenue? Okay. Is it revenues? Is it number of people who are working? So today there are 100. Is it, do I need 150? Do I need 200? Is it the number of customers that I have? I want to increase that. Okay, so I should be very clear on what is it that I'm going to look at. Now, revenue is something that every organization will always look at increasing. Okay, so need a steady growth year on year. Okay, so today I'm doing $100,000 of business. Tomorrow I want to do 150,000, then 200,000, then 300,000, so on and so forth. And I want to grow my organization in terms of revenue. But what is going to affect or impact my revenue? There are only two things that impacts your overall what we call margins or profit margins in other terms. Okay, profit margins or margins. One is revenue and the other is the cost. How much you put in your business and how much you earn of it. So when you subtract, you get your margins. So this is what every organization strives for, a better margins. Okay, so revenue is something that needs to be increased and cost is something that needs to be reduced. Now today, if with 100 people, I am able to answer 200,000 calls every month, okay, 200,000 calls every month, and each call that I answer gives me a revenue of, let's say, ₹1, just an hypothetical number. Okay, it gives me ₹1. But in order to maintain these 100 people, a facility and all the related things for these 100 people, I'm spending 75 paise out of it. My margin that remains is only 25 paise. All right. Now I want this margin to increase, which means either I increase this or I reduce this. Right now, in order to increase this, I should be able to increase this. In order to reduce this, I should be able to reduce this. You understand what I'm saying? Is it clear so far? Hello?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, how should I approach? Number one, I will have to identify some measurable matrices. Okay. So in terms of growth, in terms of number of people, in terms of number of calls, there are many more things into it. So every call that lands in takes certain time. So people take certain time to answer those calls. Let's say on an average, people take 2 minutes to answer a call. And everybody does at least 8 hours shift. And these are all hypothetical numbers. Okay. When we actually get into the real calculation by collecting historical data, the numbers may change, but then just an hypothetical calculation. If people are taking 2 minutes, 8 hours, I can quickly multiply and find out how much time is available. If everybody takes at least 2 minutes, and how many calls can I answer, right? Now, if my target is not to increase this because I'm not going to get new customers, or I'm not going to get new business from the existing customers, in order to increase this margin, I will have to reduce these numbers. So I will have to go and find out, how can I reduce these numbers? Which means that instead of 2 minutes, I will have to focus on reducing this time further to maybe 1.5 minutes or 3 minutes. I don't know right now. Okay. And that is exactly what I'm going to do. So I'm going to collect a lot of data. And I'm going to do some analysis. So mark my words here. I'm going to do some analysis on this historical data to find out what has happened. Okay, which means that I'm going to use my descriptive analytics at this stage. But analytics cannot be achieved until unless I analyze this data. So I have to do many more things. When I collect this data, I have to set the data right. I have to collect the right kind of data. I need right number of data points to be able to make certain conclusions. And then I'll have to, set this data so that I can run some analytics. Now, if I know that if I reduce this time, I have 100 people taking 2 minutes in 8 hours and taking X number of calls. But if I reduce the time, okay, to 1.5 minutes, the same number of calls in 8 hours, I would need less people. And I can run those models that if I reduce this time to 1.5 minutes, if I reduce this time to 1.25 minutes, if I reduce this time to 1 minute, how many people would I require? And that is part of analytics. I'm using this data that I've analyzed to run some analytical models to predict the future. You understand the difference now?
Yes, thank you.
Okay, I think that was a very good question. Very, very good questions. Keep asking these kinds of questions. Having said that, this is not that easy, but I'm also not saying that this is difficult. All we need to do is just learn this and put that into practice. The more you practice, the more you will get better at it. And that is the only mantra I can teach. You can gain this knowledge from anywhere. You can gain it with me right here on this classes. Not enough time for us to get to the depth of this subject, but whatever time we have, we'll utilize that so that you at least get a good start. And once you get that good start, do not stop your acceleration. Keep building, adding on to the knowledge that I'm going to give you in the 2 sessions that we are together, and then keep exploring and keep practicing, what you learn in the 2 days. Are we good? Can we move forward?
Yes.
Fantastic. Think that we think we all know what is data. Yeah, we all know what is data, right?
Yes.
Do you know what data
Yes,
is?
sir.
Other than the definition on the screen, I don't know what this definition is. I just put some definition, but what is data for you?
Data is information.
Data is information, kind of information. Okay. Okay, I'm writing something on the screen right now. Tell me what information you get out of it. So I've written something on the screen. What information can you get out of this?
Nothing, sir.
But you just said data is information.
which is in a
raw
systematic
data without proper information.
data which is in systematic manner.
So you're saying data which is in systematic manner. So you're adding on to it, but we are not able to understand what data is. And that's fine. Even, at some stage I was sitting at your site and there was somebody else who was talking about data and I didn't know how to really describe, though I thought that I know what data is. Now data is anything. Okay. So let's understand. Data is anything that is happening around us. Okay. It could be meaningful. It could have no meaning. When I say no meaning, it may have meaning, but I still haven't reached that stage of enlightenment to get meaning out of that data. Understand this. Okay. So data is nothing but it is a collection of certain facts. It could be numbers. It could be words. It could be measurements. It could only be observations or just description of things or some weird things like this. I really don't know, but it may have some meaning the moment I am able to decode what it means. And that is exactly what data analytics and data analysis helps us to do. So when we collect certain things, okay, we collect certain things and we try to make sense out of it. That's when the data becomes information. Okay, got it, guys? So data is anything,
Yes.
and every minuscule of a nanosecond, this entire world and the universe put together is generating more data than we can even think of storing that with us. Okay. And we still, as humans, we haven't reached that stage of making sense of every single data that is getting generated around us. What we are talking right now, we are interacting with each other, we are also generating data. Okay, few people will be able to make sense of it. Few people will say, I don't know what is happening, it's Greek for me, all of that. Okay, so you have to make sense of that data. Now data classification is another thing that a lot of scientists have done it the way they want to use it, and all those categorizations are okay. What I'm going to talk about and teach you guys is one of the classifications that I found to be more relevant and useful in what we want to achieve from this data output. Okay, but in broader terms, when we talk about facts, numbers, measurements, observations, descriptions, the data gets divided into two basic streams. One is qualitative and second is quantitative. Fantastic. Now, what is the difference? A broader difference of qualitative and quantitative data is qualitative data is descriptive information. What does it mean? Let's say I buy a new shirt and my friend visits me and he say, oh wow, what a smart shirt it is. Okay, so this is also a data, but this is telling you or giving you an information about an object, which is the shirt. Okay, so it is giving you some facts about an object. The quantitative data, on the other hand, is something that has got certain numbers attached to it. Okay, the other difference between qualitative and quantitative data is qualitative data can be collected. Just mark what I'm saying. I'll explain what this means. The quantitative data can be collected, but it cannot be analyzed. I cannot analyze a qualitative data in the form it is. Okay, so let's say I wear a shirt, I go out and I want to collect that how many people say it's a good shirt, not so good shirt, or very good shirt, or excellent shirt, or even the color of the shirt. So how many people say they like it? Some people will say they don't like it. Some people say it's the best color I've ever seen. Okay, so those descriptions can be collected, but very difficult to analyze in the form it is being collected. The quantitative data is a data that can be measured or counted. Measured or counted. Okay, which means whenever we have some measurements, numbers, I can do any kind of calculations, analysis out of that data. Okay, so that is a big broad difference between qualitative data and quantitative data. But qualitative data can also be analyzed, but it has to be transformed. Mark this word, transformed. It has to be transformed from qualitative side to quantitative side. Just to help you understand with an example of the same shirt. So I have collected data out of the 200 people I met today. 50 people said it's a very good color. 25 people said they didn't like the color, and rest of them, they said it's okay color. So I've got now numbers, right? I am transforming this descriptive information into some numbers, into certain categories of good, bad, ugly, right? And then this data now can be analyzed, because I'm now transforming this data into some kind of a quantitative data. Now, quantitative data again has got two streams. There are more, as I said, a lot of scientists have done this categorization basis their use. This is one of the categorizations that I found more relevant from what we want to achieve and what we do with data. So our categorization is into two, continuous and discrete. Has anybody heard about these two terms?
Yes.
Discrete and continuous.
Yes, sir.
Oh, fantastic. Now, who can help me understand what is continuous data? If you've heard about this, very good.
Population.
Population, okay. And discrete is?
Which is countable is discrete.
Okay.
Discrete
And which is
only
measurable is
isolated
continuous.
Oh, fantastic. That's one of the difference. Amazing. What can be counted is discrete. What can be
Yes,
measured is continuous.
measurable is continuous.
Fantastic. That's one of the key difference. Continuous data can be measured and discrete data can be counted. Okay, now let's build on it. Anybody else wants to tell me what is the difference they understand? Continuous and discrete. One difference we got. Anybody?
Like weight of students in a class is a continuous data.
Weight of
While-
students in a class is continuous data, while number
their
of students in the class is discrete.
classes get, yeah.
That's a very good example. Okay, fantastic. Okay, now I am going to teach you this difference in a different way, and I can bet if you understand this in this way and remember, you will never ever forget in your lifetime that what is the difference. Let's come back or come out of it this measurable and counted. Okay, so we'll focus on the measurement right now. We're not focusing on count data, but we're measuring on measurements. Okay, so continuous data is a data that can be measured using an instrument. Okay, now what is an instrument? In technical terms, we call this instrument as a gauge. We call this as a gauge. So any data that you measure using any instrument for example, weighing scale, the measuring tape, okay, pressure gauge, thermometer. So whenever you use any instrument to measure a data, that is continuous. If you're not using any instrument or a gauge, it is discrete. That is how I have learned the definition. So if I'm using an instrument to get this data, then the data by default becomes continuous. Okay, and anything which is not that has not come out of a gauge or an instrument becomes discrete. Simple way to understand. But continuous data has got certain properties as well. Okay, and so with discrete, so we'll look at the discrete properties a little later. But let's let's learn what continuous data is. So continuous data cannot be measured accurately at any given instance. Any reaction to this statement? A continuous data cannot be measured accurately at any given instance. Any reactions to this?
Like population, sir.
No, let's not talk about population. Population, I don't use any instrument. That's not continuous data.
Yes, sir. Maybe some errors can occur when we measure something. Minor errors would be there always.
Absolutely. You know a lot. You know a lot about data. And I'm really liking it. Okay. So I'll take an example so that the rest of you can understand. Let's say you have a center table in your house and you have a measuring tape. Now you give this measuring tape to 10 different people to measure all the 4 sides of a table and write it on a piece of paper in isolation. And when you come back and you want to see if all the measurements of all the people is same, I can bet that at least 2 to 3 measurements will be different. Okay, now why would that happen? There are a number of reasons to it. And some of those reasons could be, the way people are using the measuring instrument, which is your measuring tape. They're not starting from exact 0. Some may start from 0.5. Maybe somebody may start by 0.1. Some may be wearing specs like me, would add a parallax error, and the reading 100 would be read as 99.8 or 99.9, all of that. So there are 2 errors that can happen, one with the instrument itself and the other with the person who is using that instrument, called the operator. So because of these 2 errors, the continuous data cannot be measured accurately at any given instance. Okay, and that's a property. You can't challenge it. Okay, but there are ways and means to reduce, what I'm gathering or what I'm collecting. That's one of the properties. The second property of a continuous data is that it can be broken down into subunits. You can break continuous data into subunits. And some of those widely accepted measuring units that we know, the SI units or the British standard units, which is the SI units, let's say for distance, is meter. On the left hand side we go hectometer, decimeter, kilometer. On the right hand side we go the smaller units. Okay, so this is how I learned. King Henry died, mother didn't cry much. Some of you may have learned a different way. So kilo, hecta, deca, base unit, deci, centi, milli. Okay, so you can break down into subunits. So that is what continuous data is all about. Okay, so data that is measured using an instrument or a gauge cannot be measured accurately and can be further subdivided. That is continuous. And everything else which doesn't qualify this definition is discrete. Okay. Are we clear People ask questions here, make yourself crystal clear on these terms, terminologies for continuous and discrete data. This is important. I'll tell you why it is important for us to learn what kind of a data are we collecting, because the tools that we're going to use for analysis and analytics are different for continuous data and different for discrete data. So we have to be very, very careful in terms of what is the data that we are collecting and what are the different analysis we're going to run on this data. It will depend on what kind of data are we collecting.
Hi, sir.
Hello.
My question is, can we use cluster data in data analytics?
So those are terms that we will learn little later. Clusters, and all of that. So that is part of your analytics.
Okay, sir. Okay.
Creating clusters out of data. So clusters and all that is something that we do with discrete, and we can do with continuous as well. But most of the time we use it with discrete data.
Okay, sir.
Those are the analytics part. Those are the analytics part. What we are learning right now is what kind of data are we going to collect? How do we set it out for our analysis, and then take it to the analytics part, taking some predictions out of those data. So this slide just talks in more depth of what we just discussed between the qualitative quantitative data. So I'm just going to skip this slide as of now. Now this slide I'll spend some time because we spoke about the continuous part of the data, the quantitative data, continuous, which is measured on a scale or instrument. Let's talk about discrete. Now, for the ease of data collection and data analysis and the analytics tools that we're going to use, the discrete data has been divided into 5 categories. Okay. Now, this is, again, I'm saying this is how I have learned, understood the segregation between continuous, discrete, and different discrete categories by the usage of the tools that we're going to use further for our analysis. Okay, there could be way more different subgrouping that is possible and that are there. There are different terms that different scientists use to define their own categories, and that's okay, that's fine. Okay, one of the discrete categories we know is binary. Binary is basically zeros and ones. Only one outcome is possible, whether it is switched on or off, whether it is up or down, it is in or out, it is fuse or not fuse. So only one outcome possible. So if we are collecting data, did I reach office on time or not on time, is again a binary, because the outcome will either be yes or a no. Okay, so binary category. So that's one of the discrete data subgrouping. The second subgrouping is called the ordinal data. Okay, ordinal data. Now, ordinal data means in certain order. Ordinal has got 2 categories, unordered categories and ordered categories. Okay, unordered category means here it says no ranking. Let me explain what does this unordered category and ordered category mean. So I'm collecting a data on certain products that I market. So let's say I've got 10 products and I want to find out how many people they like each type of this product. Okay, so say for example, I say product 1 till 10, and I go to, let's say, 100 people, and I ask, which product do you like? So he says he likes one. Somebody else says he likes two. The next one says he likes two. Then he likes three. So I collect, 100 sets of data. Okay, I'm not putting anything into order. I'm just saying, I'm just want to see that how many people out of these 100 people like product one. Or maybe, I run a flower shop and I want to find out what are the top 5 flowers that most people buy. Okay, so I collect data. It is in no order, but those top 5 flowers that people buy. But when I say go and ask which is the top selling product, which is the second top selling product, which is the third top selling product, fourth and fifth, the moment I try to put a rank to this or rating to this data, I move from unordered category to an ordered category. Okay, so this is ordinal data. No ranking data is just useful for just a data collection. Doesn't give too much of meaningful information, but when you move it to the ordered category, you start getting certain good amount of information out of this data, which is the top selling product, which is the top selling item in my cart, what sells more on Monday, what sells more on Tuesday, what sells more on Wednesday. All of that is ordinal data in certain rank or order. You may have seen, you receive some surveys and they ask you to rank from 1 to 5, where 1 is the worst and 5 is the best. That data is also ordinal data. That is into an ordered category data. Then the next category within discrete is count. Now this is the most available data that we have. Count. Count has got a property, which is you can only count the occurrence of something, but you will never be able to count the non-occurrence of that thing. I'll take an example to explain what do I mean. So counting numbers, which is whole numbers starting from 0 and goes till infinite. That is what count category is. But you can only count the occurrence. What has occurred, you will be able to count, but what has not occurred, you will not be able to count. Okay. To run an example, can somebody count and tell me how many people are right now logged in into this meeting?
89.
Anybody has got a different number?
No.
88.
88. Now 90. Somebody joined right now. But then, at this moment, if anybody is looking at the number of 89, I see 90. I think that person is still, he must have joined now. So you will be able to
Now
see
90.
90. Yeah, now 90. So everybody sees 90, right? Okay. But now my next question is, can you tell me how many people are not there in this meeting?
No, sir.
No.
No, we cannot, which means it is rest of the world. And that is what exactly count data helps you do. It can only help you count the occurrence of something. So the people who are there, that has occurred, the event that has occurred is something that you could count, but the event that has not occurred, you cannot count. And that is what count data, discrete category is. And this is one of the most used category within discrete, the count. All right. And then the most difficult category to understand within discrete is called the percentage. Percentage, also known as proportions, because it comprises of two things, a numerator and a denominator. Right? So there are two things into the percentage, numerator and a denominator. Now, there are exceptions within each category. We have some exceptions in continuous. I'll talk about that. But I'll talk about discrete exception, and percentage is one of the exceptions in the discrete category. And let me explain you why this is an exception. Because we have to be a little careful while we work with two different type of data to get one data set. Okay. Percentage is not always out of 100. Let's try and understand. This is not always out of 100. It could be any numerator. It could be any denominator. Okay. So let's say I was expecting 203 people to attend this, and only 196 people came. This is again an example of a percentage. I can convert it into percentage. I can do this, multiply this by 100 to get the percentage. That is how we do, right? That is how we've learned how to get a percentage. You divide and you get a percentage. Now, why this is an exception? Because sometimes the numerator and denominator subgrouping helps us decide what is going to be the output. Now, there are three combinations that are possible in the percentage when we derive a percentage. There are three combinations, or proportion, as I prefer to call this as proportions rather than percentage. Proportions. Though we always term it in form of a percentage, but I prefer to call it as proportion. Okay, proportion. Now let's look at what are the three possibilities of numerators and denominators. Now, first possibility is that my numerator is going to be discrete by discrete. Okay, and this is an example. So out of 203 people, which is count data, 196 people joined, which is again count data. Okay, which means it is discrete by discrete. Now there is one more thing that comes out of a percentage, is we are now able to count the non-occurrence as well. Non-occurrence. So out of 203, if 196 joined, rest did not join, which means you can count the occurrence and the non-occurrence both when you look at a proportion. Okay, so that's another property of percentage. But the outcome of a discrete by discrete will always be termed as discrete. Okay. The second possibility is either your numerator or your denominator becomes continuous. So it could be either continuous by discrete or discrete by continuous, or vice versa. Then the outcome becomes continuous, because this continuous data will give its continuity to the discrete data and make it continuous. So this, if you have data where you have either your numerator as continuous and denominator as continuous, this no longer remains here. This moves to this side. Okay, this proportion moves to this side. I'll give you an example. I have got 10 people who are working. Okay, so they are doing a work I've given them, and I calculate how much time these people are taking to do the task. And I want to find out what is an average time that each person takes. Now, in order to get this, I need two data points, two different data points. One is how many number of people, and the second is how much time each of them has taken to do the task. So let's say each person get 10 tasks to do, and I collect data on timings of all those 10 tasks, which means for 10 people, I'll have 100, the time, and I know I've got 10 people. On an average, how much time a person has taken. So I will add all the time. Let's say it took 200 minutes by 10 people. So I will say on an average, every person took 20 minutes to complete a task. Okay. Now here my numerator is time. Time comes out of an instrument or a gauge, right? So it comes out of an instrument, which means this is continuous, but this is number of people, which is count, which is discrete. But when I get the output, it becomes continuous. And the third is both my numerator and denominator are continuous. So by default, the output becomes continuous. So which is average, or you can say speed, acceleration. All these have two components, distance upon time, right? So both are continuous. Distance comes out of an instrument, time comes out of an instrument. So the output becomes continuous. Any questions on this slide, people? Because these basics are very important for each one of us to understand. Very, very important. Any questions? Please ask. All right, that means no question. We can move forward. Now, whenever we are doing some analysis, there are two things that we will always measure, or we would always measure, because those are these two things that are going to help us get certain insights into our data. And you will hear about these terms a lot when it comes to data analysis, or specifically the analytics part of it, when you are trying to model or you're trying to do certain descriptive analysis onto your data, or even you're trying to do some predictive models, trying to build some models to forecast, predict the future. You will learn about all these terms, and these terms are a little important for us to understand. Some key statistical measurements. Now, there are two key statistical measurements we'll talk about. One is called measure of central tendency, and the other is called measure of variation. Okay. Anybody who knows what is measure of central tendency? Any idea? Measure of central tendency.
It represents a center point.
The center point. Fantastic.
Yeah,
It
average or representative of a data.
Median.
Yeah, so not only median, these are the measures.
Representative, yeah.
These are the measures of central tendency, but let's understand what central tendency is. And you're right, it represents the middle point. So just to add on what you just said, the midpoint. So basically, if I go by the definition of a central tendency, it says central tendency is that point in your data where your data set is perceived to be balanced. Okay, it is perceived to be balanced, which means that there are equal number of data points on the left of your scale and equal number of data points on the right of your scale from that midpoint. That is what measure of central tendency means. Now there are three measures which are there: mean, median, and mode. Most of the time, whenever we are doing some statistical analysis, we use mean and median. We normally do not use mode a lot as measure of central tendency. One thing that I've learned, and there may be different uses of mode, but something that I've learned from my gurus is mode is basically used when you need data in whole numbers most of the time. Okay, you need data in whole numbers. Say, for example, we're doing some census in a particular area, and we want to find out how many average number of people are there per household. Now, if somebody comes out and says there are 4.36 people per household, it may not make a sense in decimals. I may then use mode because I'm collecting data in whole numbers. I go house to house and find out how many people live in. So somebody says in some house there are 4 people, some 5 people, 10 people, 4 people, 3 people, 2 people. And then I take a mode, which is most frequently occurring value. And then I say that is, on an average, there are 3 people or 4 people per household that lives in that particular area. So for my statistical analysis, I've never used mode. I'm not saying we cannot, but I haven't used mode, and I have been advised not to use mode for my statistical analysis. But I've always used mean and median for all my statistical analysis. Do we understand what mean is?
Yes.
What is mean?
It's the average of the data. When you sum the observations divided by the total number of observation, you get the mean.
Very good. So you said it is average.
Yes.
And yes, that is average. Mean is equal to average. You do a Google search, 99.9% times you will find this as an output, that mean is a synonym of average. But there's something, I learned, and I'm not saying that what I've learned is right or wrong, but I just still want to share one thought which I learned between mean and average. And I think 2-3 slides down the line, we'll also talk about this concept. When you collect large data, basically when you have data for a population data is always very large. Okay, then what you calculate is called mean. But when you do sampling, when you pull out data from the population, and you take samples, then what you get is called average. That is some difference that I learned. I'm still saying is it right or wrong? I really don't know, but I really I liked what this article said, because when you take portion of data from population and then you're trying to calculate, if I may say, mean, then there is chances of errors in your calculation, because it is still not a population. You may sample it incorrectly. You may pull out samples which may not represent a lot of your entire population. Then you may end up doing some errors, and hence they say that somebody said, how do you calculate average is add all your data points, correct, and divide by the number of the data points. Okay, add all your data points and divide by the number of those data points. And when we actually, this article said, when you do an average, you don't always divide by the number of data points, but you divide by one less data point to get the average. Okay, but conceptually, I thought, what this article said was making sense, but none of us uses it. And just don't quote me on what I said, but then I just wanted to share something that I learned. Mean is equal to average for us as of now for our calculation perspective. What is median?
The middle value or
Middle
the
value.
average of middle value when you arrange the data in ascending or descending order.
Yeah. So when you arrange the data, if your data is odd numbers,
Then it is middle.
then the middle point. But if it is even,
then average.
Average of
Average.
middle those numbers.
absolutely fantastic, sir. Thank you so much. Then average of the middle 2 points. Average of midpoints. Fantastic. Now my question is, and it's a very obvious question, that whenever I collect some data, I have to decide on a measure of central tendency. Now, why it is important? Because let's say if I want to compare two data sets, okay, I've got 100 data points in one data set. Let's say this is the time that people have taken to do one call. And then I've got another set of data from another team, again of 100 people, the time that they took. I want to compare who took the least time. Now, I can't compare each sample with all the samples here and each sample with all the samples and similarly on the two samples. It is very difficult. Now, in order to compare this, I would need a central tendency point, right, for both these data sets. Now, my question is, what could be a better measure of central tendency? Because both are central tendency, mean and median. Should I use mean or should I use median as my central tendency to compare these two data sets? How would you react to this?
It would be better to use mean, I think.
It is
If
better
it
to
is
use
symmetrical,
Mean, I think so. I'm not sure.
Oh, that's fine. Yeah,
but the
somebody else
data,
was
if
saying
it is
something.
symmetrical, if the data is symmetrical, then it's better to use mean, otherwise median.
What do you mean by symmetrical?
Uniform or homogeneous.
Uniform, homogeneous, okay.
Like if it is, you don't have extreme values which affect your data.
Ah, now you got it. Now you got it. Absolutely. Yeah, you're all right. So let me quickly take an example and help other people understand. And you have got a better understanding, but let me help people. So let's say I've got these 5 data points in a sequence, 1, 2, 3, 4, 5. What is the mean of this data point? We can do quickly, right?
Three.
Very nice. So mean is equal to 3. And what is the median?
3.
Again 3.
Median is also 3. Fantastic. And there is no mode. So we are not talking about mode here, right? Because you cannot calculate mode. There is nothing repeating. But we have got two central tendency, mean or median. Okay. I am writing another data set. Now let's calculate. So it is 1, 2, 3, 4, 50. So what is the mean of this data point?
I think it is 12. 12.
Mean
Fantastic.
12.
And what is the median?
3.
Everybody else is on the same page, my friends.
3.
A lot of people who are not speaking, but I just want to make sure that we are on the same page. Median is 3, mean is 12. Now, what do you think Now here in this example, you take mean or median, it will not make a difference, right? So if you have a data set like this, you take mean or median, it is really not going to make a difference. But let's look at this data set. If I take mean as my central tendency, do you think it is the correct? It would give me the correct measurement of central tendency if I take mean. Yes, no, maybe.
No.
No, because mean is way far away as a central tendency point, which we learned is the middle point where both my sides of the data get balanced, because it doesn't get balanced at 12. But yes, on 3, at least 2 data points this side and 2 data points this side, at least my data points are getting balanced at the median point. So whenever we have extreme values in our data set, we say that we never use mean, but we use median as my central tendency point. Okay, so are we clear till here? Okay, let's look at the other side of the statistical measurements called variance and standard deviation. Now these are the measures of variation, but let's understand what variation is. Anybody who knows what variation is can explain
How the data is spread, like
Difference.
No, the difference in
Like
dispersion.
it is amount of dispersion.
dispersion, spread.
Yeah.
Exactly.
Okay, if a layman has to understand what these technical terms are, then I understand what you said. But if somebody who doesn't know the subject, if you have to make that person understand, how would you explain him the variation?
How each observation differ from the mean median calculated.
1 to each other.
So
How is this data is diverted or distributed comparing with the central point?
okay, central point. I think somebody said what I wanted to hear. I couldn't gather who was that person. Somebody also said each other.
It's the difference between, means if we are calculating a representative, then they help you to understand how much it is perfect. The distance between the mean or whatever central tendency you calculated with the data.
Okay. So central tendency is always used when you have to measure. But if you have to understand variation in a very simple term, and then somebody said that I couldn't gather who that person was, but then if you go by a very simple definition of variation, it means that difference between two
Yes.
consecutive data points. That is in simple terms what variation is. Okay, difference between two consecutive data points in very simple terms. So today I walk from my home to my office or work. I take 15 minutes, 40 seconds. Tomorrow when I cover the same distance, I take 14 minutes, 19 seconds. The third day I go and cover, I take 14 minutes and 45 seconds. This difference between the consecutive data points is variation. Now, when I have to measure how much is it, that's when the central tendency or the central point comes into picture. And you're all right. I'm not saying you're right or wrong, or what your knowledge is incorrect. It's all correct. Okay. Now, what is variance? So this is one of the measures of variation. Variance. Anybody
The
who knows
measure is taken with the mean. If the difference between the data is calculated with the central tendency mean, then it is variance.
And what is standard deviation?
It's the square root of variance.
Oh, absolutely correct. Okay. So variance is the average square distance of the data points from its mean or median. It could be any central tendency point. Okay. But as per the definition, it says it is the average square distance of data points from the mean. People who don't understand this, it's fine, it's okay as of now. Okay, don't take too much up on your brains if you're not understanding what I'm saying, but then, you know, I'm trying to be on the ground and I'm trying to explain. So variance is an average square distance of data points from its mean, from the mean. So what does it mean? If I may, 1 second, let me do it. My spreadsheet visible?
Yes.
Okay, so if I have to calculate variance, though we learn how to calculate using some Excel functions and functionalities, but before that, let's understand what it is. So it is the average squared distance of data points from the mean. So let's understand this. Average square distance of data point from the mean. So what does it mean? Which means first I need to calculate the mean. Okay, the mean I know is 3, which I already calculated, or average is 3. Okay, now I need, if I may have to put it in form of so in form of a statistical formula, it may look like this. Okay, so it will look like this. Okay, so this is how it is denoted, sigma square, where you have large sigma, where sigma goes from I0 till IN, xi minus mu whole square divided by n. So let's do the variance using this formula. Let's unfold this formula. So I is the n is the number of data points. Okay, here in this example, I have got 5 data points. So these iterations will go from I1 till I5. So when it comes to X1, this is this data point, then X2, X3, X4, and X5. And mu is nothing but it's the mean. So Xi minus mu. So mu is 3. If I say 1 minus 3, I will get minus 2. Then X2 minus mean. Then X3 minus mean. Then X4 minus mean. And then X5 minus mean. So I get this. So xi minus mu. Now whole square of it. So when you do whole square, you get 4, you get 1, you get 0, you get 1, you get 4. Then summation, big sigma. So you sum them all. So you get 10. Then you divide this by n. N here is 5. So you divide this by 5. You get 2. 2 is the variance of this data set. Okay, this is the average square distance of these data points from the mean. On an average, the square distance of this data point is 2. This is called variance. And then how do I get the standard deviation? Somebody said it right. You do the square root of this and you get the standard deviation. So standard deviation, maybe let's take it at only at 2 decimal points, is 1.41 for this data set. Okay, there are more complex things into it. I'm not getting right now into all those complex things, but I just want to keep it a little simple here for you to understand. This is also important. Why learning or understanding variance and variation and central tendency both is important? Because I may have a process like this, okay, where my mean or median is 3 and I am expecting it to be 3. My target that I need to achieve is also 3. Okay, but my variation here, or if I may call it in terms of standard deviation, is 1.14. That is something that we calculated. And I've got another data set, which is like this. Okay, so what is the mean for this data set? 33333. What is the mean?
3.
Yeah. People, why are you scared of saying? Yeah, mean. What is median?
3.
3 on.
And what is mode?
3.
3 on.
Fantastic. So difficult to get this kind of data sets. These are all hypothetical data sets, but then, the central tendency for these two data sets is the same. If I have to compare these two data sets, right, 1, 2, 3, 4, 5 and 3, 3, 3, using only central tendency, then I would say there is no difference, because mean median is 3, mean median is 3. But still there is a difference in the data set, and that difference can only be found out when you calculate this side of your data, which is the variation. So here the variation is 1.14, and any unit, it is unitless, so it will take the unit of your data. But here in this data, my variation is 0. There is no variation, right? So when I have to compare, I have to look at both these measurements, central tendency as well as measure of variation. Got it, people?
Yes, sir.
So rest of the slides talks about all that we have already covered. So I'm just going to, brush through them. So measure of central tendency and then measure of variation. Okay, so it's computed as average squared deviation of each number from its mean. And this is the square root of variance. Any questions from anyone on the topics that we have covered so far? Any questions? Okay, are you liking this session?
Yes,
Sir.
sir.
Yes, sir.
Okay. Is there something that you're learning new?
For sure, we are learning so much.
Yes, sir. Yes, sir.
Okay, fantastic. Now let's look at the other some few more things that we should know before we get into any analysis and all that. So we'll talk about big data, which is also known as population data, and we also look at sampling. Okay, so big data is basically everything that is possible to collect on this planet. Okay, that's population. So let's say you want to do some analysis on certain school. So a school has got 3,000 students, and you collect data for all the 3,000 students for all the years that school has been in existence. That is called the population data or the big data. But collecting big data or large population data sometimes becomes difficult for immediate analysis, right? So we rely on samples. I'm not saying we cannot collect or we should not collect big data, but sampling is the technique of taking a portion out of this big data using certain sampling techniques, and then we can do some statistical inferences on that data point. Now, when we use traditional tools like Excel or any other tools, then it becomes little difficult for us to do any analysis on the population or big data. Now, in order to do that, in order to work with big data, we would need new technologies. We would need new tools to be able to do that. And few of those tools that recently I have learned, and there are many more that are coming up. One is using R, Python, okay, SAS, and there are many more. These are few things that I've learned that helps you do lot of analytics or analysis with big data, millions and trillions of record. Even you can do real-time analysis using these applications, because they help you build models. They help you do historical analysis. Okay, they also help you do predictive analytics. They help you with every aspect of your analytics. Okay, so you need to learn programming. You attach your data sets to these programs, and you can do all those analysis, which are not possible. I'm even not saying difficult, but not possible using Excel. Excel has got limitation. So whenever I'm using Excel or certain other tools that I have learned, which is called Minitab, to do a lot of statistical analysis, then big datas become difficult. Okay, so we always rely on sample data. I have a module on sampling, but I do not have too much time at hand to really run you through different sampling techniques. But be rest assured, there are sampling methods which we use to pull out data from the population for our analysis purpose. Okay, so when it comes to Excel, we rely on samples, not on big data. Now, identifying the outcome, that's where we started, right? You remember the 6 steps in doing the analysis. The first one is to define a goal, which means identify the outcome. The starting point of any data collection is to identify why are we doing this data collection. Very, very important. So what questions do you want to get answers to? What are the desired outcomes? What matrices you want to collect data on? Now you understand what matrices are. What are the different data types? Now you also understand what the data types is. Is it continuous or discrete? Or if it is discrete, then what kind of discrete data? How are we going to measure this data? If it is continuous data, how are we going to measure it? Are we going to use some automation or automatic tools to collect this data, or are we going to use a manual way of collecting this data? So how are we going to measure it? Any other related conditions that I need to know? So if I'm collecting data for people sitting and taking calls, do I need to collect other data? Say, for example, there is a person who takes 2 minutes to do a call. There is another person who takes 1.5 minutes to do a call. There is another person who takes 5 minutes to do a call. Right now, this is the data that I'm collecting. But any other conditions that can help me do some analytics or analysis on this data? And the answer is yes. I may need to know what is his tenure. I may need to know what is his age. I may need to know what is his education qualification, any additional qualification that he holds. Has he got any hands-on experience, any previous experience? All of that are related conditions. I need to know the environment that these people are sitting in. Now most of us are working from home. slowly we are going back to offices, but last 2 years, a lot of us are, working from office, from home. So every home has got a different environment. So people with better environments are able to concentrate much on their work and able to finish more work in less time. But there are few people who may not have that luxury of big homes and their own, room to sit and do their work. They may be just sitting with a lot of noise around them. They may be distracted and they may take different time. So these are the conditions that I need to collect along when I'm collecting some data. How much samples do you need to collect? And where are you going to record these data? So these are very critical points in terms of data collection. So when you collect some data, you need to do all of this. And in order to get this, we design something called a data collection plan. So there is a template that we design, and this template is given to all the people who are helping in this data collection, so that everybody collects the right kind of data or right amount of data. So this is one template which says what questions do you need to answer, what means the relevance of this data, what do you want to do with it, what are the matrices, what is the data type, how are you going to measure this data, okay, any related conditions that you need to record, sampling notes, how much samples, and how and where you are going to record these. Okay, so these are called, these are normally recorded in called data collection forms or data collection templates, DCTs or DCFs in short forms. Right. This is an example of a data collection template or data collection form. So these will not have anything populated, but just the headers and a definition of what needs to be collected under each header. So let's say this is date, so current date, some order ID, ship date, shipping mode, customer ID, customer name, customer segment, product ID, salesman, his designation, region, number of customers he contacted, what was the net sales, any profit loss that he may have. So we create a template, give it to everybody in the team who is doing a data collection, so that everybody comes back with the same data. And we decide how many number of data points we need. We need 200 points, 1000 points, last 3 months points, last 6 months points. So that is decided as part of your data collection plan. And once we have this data, then we prepare our data sheets and we start with formatting. Now, any questions at this stage from anyone? Because now we will actually get into the practical part of what we've learned. I hope you have also downloaded those templates from that shared drive, because that is the activity that we will do tomorrow. We'll learn few things and we'll apply all of them into that case study that that we have.
Sir, which template?
In the chat box there, there is a link.
I've shared the link where you can download the worksheets. Haven't you got it?
So there are 2 Excel templates and there are 2 Word documents.
Yes. Just a second, I'll share it again.
Okay, so make sure that each one of you download that, because we're going to use that. In fact, you guys are going to use that, and you know, and that is also going to help you in keeping up in touch with, you know, things. So there are few limited things that are there, but my expectation is whatever we learn can be applied on those worksheets also. And when you do it yourself, that's when your retention becomes more easy. Okay, but today we will actually touch base with few things. I'm going to talk about this, and when you get this presentation, you will also get all these embedded files that I'm going to use when I teach you. So all these collections will help you keep up to that pace or keep your learning alive. But the only thing is that you have to keep that learning alive yourself after this session.
So you were mentioning that we'll be doing a sampling of the entire population on Excel tomorrow. So
No. We're not going to do sampling. I already have some sample data for you. We're going to use that sample data to do some analysis.
Okay, so can we assume that, you know, if sampling can be done on Excel, then small data sets of about 100 or 1000 can be done on Excel? Is that possible?
Okay, so as I said, sampling again is a science. It's a method of finding out how many numbers, and there are a lot of inputs that are required. I cannot just decide how many samples I require. So there is a statistical sampling. There are calculators that helps us to determine how many samples do we need, and then we collect those number of samples. And even the sampling methods may different for each different data types. That is another thing that that's another topic. You know, it's around an hour's topic that that we learn how to sample, and then we also have some sampling calculators. Maybe what I can do when I share this presentation, I'll also send across a sampling calculator, which you can use. Otherwise, there are a lot of sampling calculators. You can Google sampling calculator. You can download an Excel file from internet. All sampling calculators will use the same way of doing the sampling. Tomorrow, if we have some time, I may run you through some sampling calculators. What are the different inputs, and how do we decide, and how many samples can be useful? Okay.
Yes.
I wish we could also have a lot of time to learn how do we do big data analysis, because that is the need of the hour. But having said that, I'm not saying that we can't use Excel for doing a lot of things. We still can use.
So I just had a question. What are the upper limits of sampling? Like, I mean, data size that you can do on Excel?
No. You can do up to 10 lakh rows of data, but then, the Excel files become too heavy for you to manage it. You can store data. You can use that as a database. So if I look at a blank Excel file here, there is 10,48,576 rows of data. And if you want to look at how many columns, XFD around 1,600 some odd columns. So if you multiply this, it is over 11 crore data points that you can store and analyze. Correct? It's huge data, but then the Excel files become so heavy, and unless you have computers which have 30 gigs of RAM and lot of space for you to work along, it becomes difficult. Even smaller files like 48 MBs, 50 MB files becomes very heavy for me. Even when I do my reporting and my dashboarding, it takes a lot of time for me to even manage those 48, 50 MBs of data files. So I'm not saying you cannot do a lot of data points, but I'm talking about millions and trillions of records. I'll give you an example. One of the analysis that we do is called sentiment analysis. Okay. Now, sentiment analysis is done through social media. So let's say Twitter, very good example. So there is some topic that is getting discussed, and people have started, throwing left, right, center. So people are sharing, they are commenting and all of that. And I want to run, a sentiment analysis on there. I'm talking about those big numbers of data where every minutes of or every second you're generating at least 10 to 20,000 records, or maybe in a day if you talk about 10 million to 20 million records. Those records are not possible to do with Excel. For that we need certain other tools like Python or R, or other databases like SQL, MySQL, or other big RDBMS data bases where I can store the data and do some analysis. Does it make sense, my friend?
Yes, sir. Yes, sir. Okay, I've got it. So can you just share like what you would be doing tomorrow? So maybe we also could Google up and then, keep ourselves prepared, like, so, okay, this is what we're.
Okay, so one of the things that you may download or you may have already downloaded is this file. Okay, so this is what we are going to use as part of our case study. But having said that, I have different data files that I've created for different concepts, because we need to learn those concepts. So I have formatted them in a way, I've done a bad formatting so that I can teach you how to do a better formatting. So I will be using these live data files, but finally I'm going to use this data set to do our analysis. So I've done certain pre-work already on these files for you. People who have little nag of Excel can run through this, can learn lot many more things, and get prepared yourself for tomorrow. And then there is another file that is shared, which is something as a takeaway. So once you learn on this data, I expect you guys to use those files and work on your own. Okay, my friend, got it?
Yes.
Fine, sir. So we have received 4 folders. So these data is part of those 4 folders.
You must have received one folder and 4 files, right?
Yeah, 4 files. Yeah, exactly.
Yeah. So there are 2 Word documents. Those are some, so project deliverables, as case studies. And then these are underlying data. So there are 2 data sets. One is pharma project solve activity. And there is another one. Which is e-commerce dashboard. And there are 2 Word documents which talks about the business scenarios for e-commerce and pharma. But I'm not going to only limit to this, but we will explore more. So this business scenario for the pharma project has got certain steps also for you to for as a help that how do you achieve those outputs. Okay, so this is a guide. So you can use this guide to get these dashboards created. But I'll teach you, shorter ways of getting to these dashboards using certain other tools like pivots. We can achieve these dashboards much easier. But then these, as I said, there are multiple ways of achieving an output on Excel. Okay, and it really depends on who is using Excel and how much he's got nag of it. So this is another scenario, which is the e-commerce one. A little different dashboarding. Again, it has also got a guide. So there are different things, but we'll learn a lot of these things outside of this. But I expect you to then use your knowledge and solve this yourself. You still have all the guides here on both these scenarios. How do you achieve these things?